Good morning, students. Today we will discuss few important formulas which are based upon the number of functions. So if we have a function f defined from a to b and number of elements in set A is let us say m, and the number of elements in set B, let it be n, right? So here if you are getting confused with n, let it be t is representing the number of elements in set A and set B, right? Then number of functions that can be defined from A to B is equals to n raised to power m. So how many functions can be defined from A to B? The number of functions will be n raised to power m, where what is n? N is the number of elements present in B, and what is m? M is the number of elements present in A, right? Now the next thing is here number of 1 functions that can be defined from A to B. Number of 1 functions from A to B. This is given by, first of all, the first formula that we will have, it is given by npm. When it will be given npm, whenever we have m less than or equal to n, and it will be 0 if I have m greater than n. Now remember, m and n I am keeping not m greater than n, because here we will have yes, because here if I have m less than or equal to n. Now what is m? M is the number of elements in set A and n is the number of elements in set B. So if I have to find how many 1 functions that can be defined from A to B, it will be npm, right? And if you remember, this is the total number available, and this is how many number we are selecting. If you remember the concept of permutation, so it will be npm. In place of r, what is what we are taking here? M we are taking. So npr formula, I hope everybody remembers, right? And by chance, if m is greater than n, right? By chance, that means what is m? M is the number of elements in set A. Okay, if m is greater than n, then how many 1 functions can be defined? Then the number is 0, right? And if m is equals to n, if A set and B set are having the same number, if A set and B set are having the same number, then what will happen? How many 1 functions will be there? It will be npn, right? So what is npn? I hope you remember what is the formula of npr. Npr is given by n factorial upon n minus r factorial, right? This is the formula of npr, and when I have r is equal to n, what we will get here? N factorial upon n minus n factorial, which is equals to n factorial. It means, in other words, I can say number of 1 functions from A to A, because when I take the functions from A to the set A itself, right, that means domain and codomain both are same, then how many 1 functions can be defined? If we know that the number of elements in set A is m, then number of functions that will be defined, it will be m factorial. Okay, so this is the result. First of all, how many 1 functions can be defined. Similarly, we have that how many onto functions that can be defined. Number of onto functions from A to B. How will we get that? The formula remains like this. It will be equals to summation minus 1 raised to power n minus r ncr and r raised to power m, where what is now here r is will vary from 1 to n, And m is, what is m here? Definitely m is the number of elements present in the set A. And what is n? N is the number of elements present in set B. So here NCR formula is coming. NCR means combination formula. So remember, whenever we have this 1 functions, we have permutation formula, but when I have number of 1 functions from set A to itself, it will be m factorial. Similarly, number of onto functions will be given by minus 1 raised to power n minus r, summation we are taking, right? And NCR, that means here we are using the combination formula, NCR r raised to power n m. This is we have to mention when it will happen, whenever n is less than or equal to m, right? And it will be 0 when I have n greater than m. If you remember, the relation is exactly opposite. In this 1 function, m was less than or equal to n, then npm is the number of 1 functions. That means number of elements in A is less than or equal to number of elements in set B. Then 1 functions are there. But in onto functions, what is happening? Number of elements in the codomain is less than or equal to number of elements in the domain. Then this formula we will use. And if number of elements in codomain is greater than the number of elements in domain, then it will become 0, right? And whenever same result, if I have taken here the number of 1 functions from A to A, it will be m factorial. Even number of onto functions from A to A, right? Number of onto functions from A to A, that will be given by, if I know number of elements in set A is m, then that will be again m factorial only. So this result is true. When m is equal to n, it will be m factorial, right? When function is 1, how many 1 functions can be formed from the set A to set A itself? It will be m factorial if m is the number of elements of set A, right? And even 1 also, and for onto also same result true, holds true. That means for the bijection, whenever how many in other words, if I say how many bijections can be there from set A to set A, it will be given by m factorial if set A is having m element. And if A and B are different sets and they are not equal, then it will be 0. That result is used very rare in our sums. Actually, based upon these results, you people can have MCQ sums, not the solving sums. So this is the reason I have given you the formulas. You people can note down these formulas and can be used in MCQ sums. And here in our miscellaneous exercise, sum number 10 is also based upon this only. So if I take you to sum number 10, what is the sum number 10 of miscellaneous exercise? The question says, find the number of all onto functions from the set. If I take the given set, let it be A. What are the elements here? 1, 2, 3 up to so on n, right? To itself. So we have to find number of onto functions from A to A. Now how many elements A set is having? First, n natural numbers are there in set A. So we will write down number of elements in set A, it is n. And just now we have done the formula. If the set is having m elements or n elements and we want the number of onto functions or number of 1 functions even from the set A to itself, that will be given by, we will write down, therefore number of onto functions simply will be equals to n factorial. So we have now standard result which I have just given you, right? You people should note down those results, and we are using. And even if in some it is asked how many 1 functions can be there from the set A to itself, so we will just see how many elements are there in set A. For example, set A, instead of first 10 natural numbers, if set A is having 10 elements, then how many onto functions and how many 1 functions can be there from A to A? It will be 10 factorial, right? This is how we can use the result in our sums. Okay, the next sum, that is sum number 15, because 11, 12, 13, 14 are removed from the syllabus now. So we will do now sum number 15, and sum number 15 says A is a set. A set is given, it is having the elements -1, 0, 1, 2, and there is another set B which is having the elements -4, -2, 0 and 2. And f and g both are defined from A to B. F function and g function both are defined from set A to set B by first function fx. What it is doing? X square minus x for all x belongs to A, that is the domain. And g, what is doing? G is given, it is taking twice of modulus x minus 1 by 2 minus 1, and this x is also coming from the set A. We have to check f and g, are they equal or not? Are f and g equal? And we know when two functions are equal, right? When two functions are equal, when they have the, if I take f for example, for every x belonging to the domain, if f and g are two functions, for every x belonging to the domain, if I prove fx is equal to gx, that's it. For every x belonging to the domain, if fx is equal to gx, it means the functions are equal functions. That means what we will do, how many elements are there in the domain? 4 elements are there. I will find f of -1, the g of -1, f of 0, g of 0, f of 1, g of 1, f of 2, g of 2. If under these two functions f and g, the image of -1 under f is equals to image of -1 under g, image of 0 under f is equals to image of 0 under g. If it comes true, that means the functions are equal. So first of all, we will find here f of -1. Now what is function f doing? It is doing the square of the given number minus that number. So here we will get -1 square minus of -1. That means 1 plus 1, it is actually 2. Let us find what is g of -1. What is g doing? It is taking twice modulus in x. In place of x we will put -1. This -1 by 2 as such -1. So what will happen here? Modulus we are getting -3 by 2 -1. That means it will be 2 into 3 by 2 minus 1. If you remember, modulus will always give us the positive answer. So here we will get 3 minus 1, it is 2. So what we are getting here, that f of -1 is equals to g of -1. Similarly, you people will find f of 0 and g of 0. What will be f of 0? It will be 0 square minus 0, that is 0. G of 0 will be modulus 2 times modulus 0 minus 1 by 2 minus 1. So that will be 2, 1 by 2 minus 1, it is 0. Likewise, we will find f of 1, g of 1, f of 2, g of 2, and here we will see all images are coming equal, and finally we will say that the functions are equal functions. Okay, I hope you people can complete this sum number 15. Two more things you people have to do, f of 1, g of 1, f of 2, g of 2, and the sum will be done, right? And now sum number 16 and sum number 17 we will do. In sum number 16 and sum number 17 also, one simple thing is here that we will take care of. And what is that simple thing? Let me tell you. First of all, let us see what is sum number 16 saying. Sum number 16 is set A is given here, which is having the elements 1, 2 and 3. 1, 2 and 3. And we have to find the number of relations containing 1, 2, 1, 3. So we have to find the number of relations, right? They should contain these two elements. What are the elements? 1, 2 and 1 comma 3. These two elements should be there such that the relations are which are reflexive and symmetric, reflexive and symmetric, but not transitive. Now the relation should be reflexive, relation should be symmetric, but it should not be transitive. Now A set is given here. So what we will do? Here, in order to prove that the relation is reflexive and symmetric, let us first of all write down all the possible ordered pairs that A can have in different relations, right? What we are getting when we are writing here, let us write down all the possible ordered pairs. Why we are writing this thing? Because from all the possible ordered pairs we will write down which ordered pairs if I take, the relation will become reflexive and symmetric but not transitive. What are the possible ordered pairs? 1 1, 2 2, 3 3, 1 2, 2 1, 1 3, 3 1, 2 3, 3 2, right? That's it. So these are the possible ordered pairs that can be made. Now let us say R1 relation, because we have to find how many relations. Let us say this is the first relation, and according to the statement the relation should contain 1 2 element and 1 3 element. If I say 1 2 element is there and 1 3 element is there, now these two things which are must that we have written. Now the relation should be reflexive and symmetric. The elements we are having 1 2 and 3 also. When the relation will be reflexive? When I have 1 1, 2 2 and 3 3. Now if I look at this relation, the relation is reflexive, 1 1, 2 2, 3 3 are there. The relation is, I need the relation to be symmetric also. Now if 1 2 is there, what should I have here? I should have 2 comma 1 also. Only then I can say the relation is symmetric. If 1 2 is there, 2 1 should also be present. So now if 1 3 is there, what is the next thing? 3 1 also should be present. Only then this relation will become symmetric. These three ordered pairs are making the relation reflexive, and when I say 1 2 is there, because it has to be, so 2 1 must be there, only then the relation is reflexive. If 1 3 is there, then 3 1 should be there to make it symmetric. Now this is the first relation that is symmetric. Let us see how many ordered pairs are used and what is left. 1 1 is used, 2 2 used, 3 3 used, 1 2, 2 1 used, 1 3 and 3 1 also used. Now these two ordered pairs are left. Okay, let us see if in the next relation I take these two ordered pairs also. First of all these ordered pairs 1 1, 2 2, 3 3 will be there, 1 2 and 1 3. These two ordered pairs have to be there according to the statement, and because the relation is symmetric, if 1 2 is there, 2 1 also there, 3 1 also there. Now if I take any one ordered pair from here, let us say 2 3, if I take, now 2 3 is if I am taking, and regarding this ordered pair 2 3 and the relation should be symmetric, then I have to take 3 2 ordered pair also. Now when I am taking 3 2 ordered pair, the relation is symmetric. It is done. Now one other problem will come. What is the other problem? When I am saying like when I say 1 2 is present, 2 3 is present, and 1 3 is also present, that means the relation is becoming transitive also. If I take here 2 1 is present, or 1 3 is present, 3 2 is present, and then 1 comma 2 is also present. So here what is happening, due to 2 comma 3 and 3 comma 2 ordered pairs, R2 has become transitive also. So it can't be considered. because the relation should not be transitive. It can't be considered. Now, how many relations are left, or how many relations we are having here which are reflexive and symmetric but not transitive? There is only one relation which is reflexive and symmetric but not transitive. If you want, I can explain here also. In R1, what we are having, 1 1, 2 comma 2, 3 comma 3 belong to R1, so reflexive. 1 2 belong to R implies 2 comma 1 also belong to R, not R1, and 1 comma 3 belong to R1 implies 3 comma 1 also belong to R1, that is R1 is symmetric, right? But in R2 what is happening? In R2, when I say 1 2 comma 2 3, these two ordered pairs belong to R, then the relation between 1 and 3, that is also present. 1 3 element is also present in R2, so the relation R2 is reflexive, symmetric as well as transitive, so which is not possible. We are not supposed to consider that relation. So what we will say, there is only one relation which will be reflexive and symmetric but not transitive, so A option will become the answer. Okay. Similarly, sum number 17 you people can do. Here you have to find all the equivalence relations containing 1 2. Equivalence relation means the relation should be reflexive, symmetric as well as transitive. All the three conditions should come true. And how many relations will be there? Definitely there will be two relations. You people can try the sum. If anybody get any doubt here, you can ask. Right, with this your exercise is complete. It's exercise of miscellaneous exercise of relation and function chapter, and the next topic that we are supposed to discuss, we will discuss in the next class. Thank you, students.